First 5 questions are going to cover the absolute basics of this type of problem, where we're given a curve and we're required to find the equation of a tangent, possibly the equation of normal. So that's what we're going to do in the first few questions. First 5 questions, we're going to find the equation of a tangent to the given curve and find the equation of the normal to the given curve at 2 particular points. So starting with question 1, a curve has equation f of x equals 4x squared plus 3x cubed minus 3. We're required to find the equation of the tangent at x equals a half, and then we're required to find the equation of the normal at x equals 1. So starting with A, I'm just going to write the curve in descending powers of x, so 3x cubed plus 4x squared minus 3. Now to find the equation of a tangent, right? The equation of a tangent is a straight line. The general equation of a straight line is given as y equals mx plus c. So to find the equation of a straight line, we need to know what the gradient is. And we need one point that lies on the line. So given all that we are given here is the fact that we've got the equation of a curve. Now, if we just took a straight line, we wanted to determine the gradient of a straight line, we're generally given 2 points, right? And we know that the gradient of a straight line is given by y2 minus y1 over x2 minus x1, which is also written as delta y over delta x. Now, we are not given 2 points, so we actually can't use this. This is not an option to find the equation of a straight line because we don't have 2 points. We do have 1 point. They gave us that x equals a half, so we can actually find the point of contact by substituting x equals a half into f of x. So we'll do that first. We'll find the value of f of a half, which is 3 times a half cubed plus 4 times a half squared minus 3. That will be 3 over 8 plus 4 over 4, which is 1, minus 3. That's 3 over 8 minus 2, which is minus 13 over 8. So the point of contact will be the point of half minus 13 over 8. And we always leave our solutions, answers, whatever it may be, in as a fraction. We are not working with decimals at all. So this is the point of contact between the tangent that we're looking to find the equation for and the curve f of x. So we've got the point, right? That's the point of contact over there. We now need to find the gradient of the tangent. Now to find the gradient of the tangent, we are going to be differentiating the curve. The reason we do that is because the derivative of a curve will give us the gradient function, right? The average gradient. In other words, the gradient of a tangent to the curve. So we are going to differentiate this function, f prime x. That will give us 3 times 3 is 9. That's 9x squared plus 8x. This expression, 9x squared plus 8x, represents the gradient of a tangent to f of x, any tangent. Now, if we want to know this specific gradient of a specific tangent to f of x, we are going to use the point of contact in this case, x equals a half. That's the x coordinate of the point of contact. So to find the value of the gradient of the tangent to f of x, the curve, at the point where x equals a half, we're going to substitute x equals a half into the gradient function. So we're going to find f prime a half, which is 9 times a half squared plus 8 times a half. That will give us 9 over 4 plus 8 times a half will be 4, and that will give us 9 plus 16, that's 25 over 4. 25 over 4 represents the gradient of the tangent to f of x at the point a half minus 13 over 8. Now that we have the gradient of the tangent and we've got the point of contact, we can determine the equation of the tangent. So y equals mx plus c. Y is minus 13 over 8. Gradient is 25 over 4. X is a half, and we obviously need to find c. So minus 13 over 8 equals 25 over 8 plus c. So c will be minus 38 over 8, which simplified is minus 19 over 4. Therefore, the equation of the tangent to f of x at the point a half minus 13 over 8 is given by y equals 25 over 4 x minus 19 over 4. And we can write this in a better way as 4y equals 25x minus 19. Either of these forms are acceptable for the equation of the tangent to f of x at the point a half minus 13 over 8. We can illustrate the equation of the tangent at the point a half minus 13 over 8. We can sketch both the equation of the tangent and the curve f of x. This is not required, by the way. This is just for illustrative purposes that you can see what's happening with a particular problem. Okay, next we're required to find the equation of the normal at the point where x equals 1. Now, a normal is perpendicular to a tangent. And we know that when two lines are perpendicular, the gradient, the product of the gradients of those two lines is always negative 1. For any two perpendicular lines, this always holds true. Gradient 1 times gradient 2 equals negative 1. Now, we need to know that the normal is perpendicular to a tangent, otherwise we can't find the equation of the normal. So, to find the gradient of the normal, we are first always going to determine the gradient of the tangent. Now, we know the gradient of the tangent is given by f prime x. Right, we have a different point here, so the gradient of the tangent in the previous question no longer applies because we are required to find the equation of the normal at the point where x equals 1, not x equals a half, as previously. So the gradient of the tangent is given by f prime x, which we know is 9x squared plus 8x. This expression represents the gradient of the tangent to f of x at any point. Now, to find the value of the gradient of the tangent to f of x, where x equals 1, we are going to determine f prime 1, which is 9 times 1 squared plus 8 times 1. That's 9 plus 8, which is 17. 17 represents the gradient of the tangent to f of x at the point where x equals 1. Now we're going to determine the point of contact as we did previously. We're going to take x equals 1 and substitute it into the function f of x. So f of 1 will be 3 times 1 cubed plus 4 times 1 squared minus 3. That's 3 plus 4 minus 3, which is 4. So the point of contact is 1, 4. This is the point of contact between the tangent to f of x and f of x at the point x equals 1. So we've got the point of contact, which is what we want. Now recall that, again, a normal is a straight line. It's a straight line that's perpendicular to a tangent. So again, to find the equation of a straight line, we're looking to find m, the gradient, and we need a point. Now we've got that point. We've got the point of contact. We now just need to find the gradient of the normal. But before we find the gradient of the normal, we are first going to find the gradient of the tangent at the point of contact, which we know is 17. Okay, so the gradient of the normal times the gradient of the tangent is -1. We know this because a tangent and a normal are perpendicular to each other. So the fact that we know that the gradient of the tangent to f of x at the point of contact 1, 4 is 17, we know that the gradient of the normal is the negative reciprocal of 17, which is a -1 over 17. So we have the gradient of the normal, we have the point of contact, we can now determine the equation of the normal at the point of contact. So y equals mx plus c, y is 4, the gradient is -1 over 17, x is 1, we're looking for c, so 4 equals -1 over 17 plus c. C will be 4 plus 1 over 17, which is 69 over 7. The equation of the normal will therefore be y equals -1 over 17 x plus 69 over 17. A better form would be 17y equals minus x plus 69. An even better form would be 17y plus x equals 69. And this is the equation of the normal to f of x at the point of contact, which was 1, 4. Then we can verify this by sketching the function f of x and the normal. Now the normal is given by this line in blue, 17y plus x equals 69. The tangent is the green straight line, that is green, and the equation is given by y equals 17x minus 13. As an exercise, I'd like you to verify that this is the equation. This is now the tangent, the equation of the tangent to f of x at the point 1, 4, and the blue line is the normal to f of x at the point 1, 4. Question 2. A curve has equation y equals 2x cubed minus x squared plus 1. We're required to find the equation of the tangent at the point where x equals a half, and we're required to find the equation of the normal at the point where x equals minus a half. So again, two different questions, but the same principles still apply. To find the equation of the normal, we're going to need to know the gradient of the normal and a point that lies on the normal. To find the gradient of the normal, we're first going to have to find the gradient of the tangent. Now, this curve is given in this form y equals. I find it preferable to express a curve in terms of f of x. It really doesn't make a difference whatsoever. It's just easier to work with. If you want to work with y equals 2x cubed minus x squared plus 1 and do so, when you find the gradient of this curve, it will be expressed as dy dx. When you find the gradient of f of x, it will be expressed as f prime x. It's just a notation, just a convention. It's not necessary to use one or the other. It's just a preference. So again, to find the equation of a tangent, the tangent is a straight line. We need the equation of a straight line is y equals mx plus c. So to find the equation of a straight line, we need to find the gradient, and we need to know one point to find the equation of that line. So we'll start this time, we'll start off by finding the gradient of the tangent. To find the gradient of the tangent, we differentiate the function. F prime x represents the average gradient of a curve, right, which approximates as the gradient of a tangent to the curve at a particular point. So f prime x, the derivative function, the gradient function for f of x will be 6x squared minus 2x. This expression represents the gradient of the tangent to the curve f of x at a particular point. Now, to find the exact value of the gradient of a tangent to a curve, we need to know the point of contact. So the point of contact will be where x equals a half. So we're going to find, we don't have to find the point of contact right now because we know x equals a half. We're going to evaluate the gradient at the point where x equals a half. So f prime of a half will be 6 times a half squared minus 2 times a half. There will be 6 quarters, which is 3 over 2 minus 2 times a half, so minus 1. 1 and a half minus 1 is a half. A half represents the gradient of the tangent to f of x at the point where x equals a half. To find the point of contact, we can substitute x equals a half into the function. So f of a half will be 2 times a half cubed minus half squared plus 1. That will be 2 over 8, which is a quarter, minus a half squared minus a quarter plus 1. That equals 1. So the point of contact between the tangent and the curve will be the point a half 1. So we have the point of contact, right? We've got the point of contact and we've got the gradient, which is a half. So we can determine the equation of the tangent at this point of contact. So y equals mx plus c. Point of contact is a half 1, y equals 1. M is a half, x is a half, plus c. So c will be 3 quarters. So the equation of the tangent at the point a half 1 to the curve will be y equals a half x plus 3 over 4. Maybe better to express this as 4y equals 2x plus 3. And this represents the equation of the tangent to f of x at the point of half 1. Again, we can illustrate the equation of the tangent at the point half 1. So here's your point of contact. The straight line is the tangent to the curve f of x. Part B. To find the equation of the normal at the point where x equals minus a half, we are first going to determine the gradient of the tangent to f of x at the point where x equals minus a half. So the first thing we do now is find the point of contact. So f of minus a half will be 2 times minus a half cubed minus a half squared plus 1. It will be minus 2 over 8, so it's going to be minus a quarter minus a half squared, so it's going to be minus a quarter plus 1. That's minus a half plus 1, which is a half. So the point of contact will be the point minus a half. So this is our point of contact. Remember that normal is just a straight line. And to find the equation of a straight line, we need to know the gradient of the line and one point which we know is the point of contact here. So we've got the point. We now need to find the gradient of the normal. But before we can find the gradient of the normal, we're going to need to find the gradient of the tangent at this point of contact. So the gradient of the tangent is given by, gradient of the tangent to the curve is given by f prime x, which is 6x squared minus 2x. The value of the gradient of the tangent at the point minus a half will be f prime minus a half, which is 6 times minus a half squared minus 2 times minus a half. That will be 6 quarters, which is 3 over 2. That's plus 2 times a half, so it will be plus 1. 1 and a half plus 1 is 2 and a half, which is 5 over 2. Leave it as a fraction. 5 over 2 represents the gradient of the tangent to f of x at the point of contact minus a half. Therefore, because the normal is perpendicular to the tangent, the gradient of the normal is the negative reciprocal of 5 over 2, which is minus 2 over 5. We now have the gradient of the normal. We have the point of contact. We can now determine the equation of the normal. So y equals mx plus c. Y is a half. Gradient is minus 2 over 5. X is minus a half. So a half equals a fifth plus c. C is a half minus a fifth. So c will be 3 over 10. So y equals minus 2 over 5x plus 3 over 10, and a better form is 10y equals minus 4x plus 3, and even better form would be 10y plus 4x equals 3. It's just a neater way to express the equation of an normal. So these forms represent the equation of the normal to f of x at the point minus a half. Then we can illustrate the tangent and the normal at the point minus a half. The line in green is the tangent, which has the equation 4y equals 10x plus 7, which you can verify. The gradient of the tangent is 5 over 2. The point of contact is minus a half. So y equals mx plus c would have a half equals 5 over 2 times minus a half plus c. A half equals minus 5 over 4 plus c, and c is therefore 7 over 4. So the equation of the tangent is y equals 5 over 2x plus 7 over 4, which is equivalent to 4y equals 10x plus 7. The curve has equation y equals x squared plus x plus 2. Find the equation of the tangent, which is parallel to y equals minus x minus 4, and then find the equation of the normal to the curve, which is parallel to y equals minus x minus 2 equals 0. Okay, again, this particular question basically just confirms that it's far easier. It doesn't confirm anything, it just makes it a lot easier if you use f of x notation or g of x. Right? So we can call the curve f of x, which is f of x equals x squared plus x plus 2. Then we can call the equation of the tangent. The equation of the tangent, let's just say that this equation will be g of x, and in this particular line, y equals minus x minus 4, let's just call that h of x. Okay, it's just a notation, and when you're working with different functions, it's just so much easier if you actually give the functions a label, which is why the f of x and g of x and h of x notation is so much easier to work with. Okay, so let's go back to what we are required to do. We are required to find the equation of a tangent. So back to basics. A tangent is a straight line of the form, and straight lines are of the general form y equals mx plus c. To find the equation of a straight line, we need to find the gradient, and we need to know a point that lies on that line. We are not explicitly given a point here, so we're going to have to do a little bit of work here to find the point of contact. Okay, so we do know that the equation of the tangent, the equation of the line we are looking to find, is parallel to this particular line h of x. Okay, so h of x equals minus x minus 4. The fact that the equation of the tangent, which is the line we're looking to find the equation for, is parallel to h of x. So g of x is parallel to h of x, we know that the gradient of g equals the gradient of h, because that is the definition of parallel lines. Parallel lines have got equal gradients. So the gradient of g equals the gradient of h. The gradient of h we know is -1 because we've got the equation of h of x. Okay, so the fact that the gradient of h is -1, that means the gradient of g is also -1. So straight away we have got the gradient of g of x, which is the tangent. So we have that the gradient of g is -1, but we don't have a point of contact. And we need to find the equation of a straight line, we need the point of contact as well. So the fact that we are given a curve, f of x equals x squared plus x plus 2, we know that differentiating this function, f of x, so finding f prime x, is going to give us the gradient of a tangent to the curve. So f prime x equals 2x plus 1. Now we know that the gradient of g is the tangent to the curve f of x. We know that the gradient of g is -1, but we also know that the gradient of the tangent to f of x is represented by 2x plus 1. So what that means is 2x plus 1, which represents the gradient of a tangent to f of x, equals -1. And we've just determined that -1 is the gradient of the tangent. So 2x plus 1 equals -1. 2x therefore equals -2, and x equals -1. This is what we need, because this represents the x coordinate of the point of contact. So we can substitute -1 into the function f of x. F of -1 equals -1 squared plus -1 plus 2. That's 1 minus 1 plus 2, which equals 2. Therefore, the point of contact is the point -1, 2. We now have the point of contact, and we have the gradient. So we've got the gradient, -1, and we've got the point of contact, -1, 2. So we can determine the equation of the tangent. So y equals mx plus c. Y equals 2. The gradient is -1. X is -1. So therefore c equals 1. And therefore y equals minus x plus 1. This now represents the equation of the tangent to f of x at the point -1, 2, and this is g of x. So basically we can also just write this as g of x equals minus x plus 1. And again, we can verify this graphically. B, we're now required to find the equation of the normal to the curve, which is parallel to y minus x minus 2. We'll call this j of x, since we've already used g of x and h of x, just to differentiate it from the rest. So we'll just write this in standard form. So y equals x plus 2. So j of x equals x plus 2. Now, we're required to find the equation of a normal. Again, let's go back to basics. A normal is a straight line. The general equation of a straight line is y equals mx plus c. To find the equation of a straight line, we need to find the gradient, and we need to know one point that lies on that line. So, since we're required to find the equation of a normal, we need to find the gradient of a normal. Now, the gradient of a normal times the gradient of a tangent is -1. So the first thing we need to do is find the gradient of the tangent, where at the point, we need to find this point again. So we're not given an explicit point, we need to find what that point of contact is. So what we can do first is determine the gradient of the tangent, which is given by the derivative of the curve f prime x, which is 2x plus 1. 2x plus 1 represents the gradient of the tangent to f of x at a particular point. To find that particular point, now we are told that the normal is parallel to j of x. Let's just call the normal k of x so we can use that terminology. Now, k of x is going to be parallel to j of x. Okay, that means that the gradient of k is equal to the gradient of j. Because when two lines are parallel, they've got equal gradients. Now, the gradient of j, that's why we wrote this in standard form. The gradient of j is the coefficient of x here, which is 1. So the gradient of k is 1. This is the gradient of the normal. So we've got the gradient. That's great. Now we just need to know, we've got the gradient of the normal. We now just need to know what the point of contact is. So the gradient of the tangent is given by 2x plus 1. That means that the gradient of the normal is given by the negative reciprocal of 2x plus 1. In other words, the gradient of the normal is minus 1 over 2x plus 1. If you're not sure about that, then just use this formula here. Gradient normal times gradient tangent is negative 1. The gradient of the normal times the gradient of the tangent, which is 2x plus 1, equals negative 1. And therefore, dividing both sides by 2x plus 1 gives us minus 1 over 2x plus 1. Right, so we've got the gradient of the normal. And the gradient of the normal is also equal to 1. So in other words, minus 1 over 2x plus 1 will be equal to 1. Now we just solve for x. So minus 1 equals 2x plus 1. 2x equals minus 2, x equals negative 1. X equals negative 1 represents the x-coordinate, the point of contact between the normal and the curve. So to find the point of contact, we can substitute x equals minus 1 into the function. So f of negative 1 will be minus 1 squared plus minus 1 plus 2. So that will be 1 minus 1 plus 2, which is 2. So the point of contact will be the point minus 1, 2. So we've got the point of contact, we've got the gradient of the normal, which is 1. Therefore, we can find the equation of the normal. Y equals mx plus c. 2 equals 1 times minus 1 plus c. C equals 3, so y equals x plus 3 is the equation of the normal to f of x at the point minus 1, 2. And again, we can illustrate this graphically. Then we can verify that the equation of the tangent is y equals minus x plus 1. And the gradient of the normal is 1. So the gradient of the tangent is negative 1. Point of contact is 1, 2. So the equation of the tangent, y equals mx plus c. 2 equals, the gradient is negative 1. X is negative 1 plus c. 2 equals 1 plus c, c equals 1. And therefore y equals minus x plus 1. And this is the equation of the tangent to f at the point minus 1, 2. Curve has equation y equals x squared plus 5x minus 2. We're required to find the equation of the tangent, which is parallel to y equals x plus 4. And we're required to find the equation of the normal to the curve, which is parallel to 2y plus x minus 4 equals 0. Again, we're going to call all of these functions f of x, g of x, etc. So f of x is x squared plus 5x minus 2. We will call g of x the tangent. We'll call the tangent g of x. Y equals x plus 4. We will call h of x. And we're going to worry about part B when we get there. So to find the equation of a tangent, okay, a tangent is a straight line. Y equals mx plus c represents the general equation of a straight line. To find the equation of a straight line, we need to know the gradient of the line and one point that lies on the line. So to find the equation of a tangent, we're first going to find the gradient of the tangent. The gradient of a tangent we can get from a curve by differentiating that curve. So the gradient of the tangent we're going to get from f prime x, which equals 2x plus 5. The tangent g of x is parallel to h of x. So we know that g of x is parallel to h of x. That means that the gradient of g equals the gradient of h. That's the definition of parallel lines, is that they have equal gradients. Now, looking at h of x, you can see that the gradient of h of x is 1. That's the coefficient of x. So we know that the gradient of g is 1. That's the first thing. The gradient of g is 1. G is the tangent we're looking to find the equation for. To find the equation of a straight line, we need the gradient in one point. We've got the gradient. There it is. It's 1. Now we need to find the point of contact. Now we need to, as before, find this point of contact. The gradient of g is 1, and the gradient of a tangent to f of x is represented by f prime x, which is 2x plus 5. So in other words, 2x plus 5, which represents the gradient of a tangent, equals 1. So 2x equals negative 4, x equals minus 2. X equals minus 2 represents the x coordinate of the point of contact between the tangent and the curve. So we need to find this point of contact, and we're going to do that by substituting x equals minus 2 into f of x. So f of minus 2 equals minus 2 squared plus 5 times minus 2 minus 2. It's going to be 4 minus 10 minus 2. 4 minus 12 is minus 8. Therefore, the point of contact between the tangent and the curve is the point minus 2 minus 8. We can now determine the equation of the tangent. So know the gradient is 1. So y equals mx plus c. Minus 8 equals 1 times minus 2 plus c. So c equals minus 6. Therefore, y equals x minus 6 is the equation of the tangent to f of x at the point minus 2 minus 8. Again, we're going to illustrate this graphically. At B, we're now required to find the equation of the normal to the curve parallel to 2y plus x minus 4 equals 0. Again, okay, we're just going to call this expression here, we'll call it j of x, just putting this into standard form. 2y plus x minus 4 equals 0. 2y equals minus x plus 4, y equals minus a half x plus 2. This is now j of x. So j of x equals minus a half x plus 2. And f of x is x squared plus 5x minus 2. Now, the equation of the normal, the equation of the line we're looking to find, is parallel to j of x. So let's just call the normal k of x. So we know that the normal is parallel to 2y plus x minus 4 equals 0. In other words, k of x is parallel to j of x. That means the gradient of k equals the gradient of j. That's why we put j of x into standard form, because the gradient of j is minus a half. So the gradient of k, the gradient of the normal is going to be, minus a half. We now need to know the point of contact. Once we have the point of contact, the normal being a straight line, we're going to use y equals mx plus c. We've got the point of, we've got the gradient, which is minus a half. We need the point of contact, and then determine the equation of the normal. So the gradient of the normal is minus a half. That means that the gradient of the tangent is going to be 2. That's important because we know that if prime x equals 2x plus 5, this represents the gradient of a tangent, any tangent, to the curve f of x. Now, since we have the gradient of a tangent being 2, we can say that 2x plus 5 equals 2, 2x equals minus 3, x equals minus 3 over 2. X equals minus 3 over 2 represents the x coordinate of the point of contact between the normal and the curve. Now, to find the point of contact, we can substitute x equals minus 3 over 2 into the curve. So f of minus 3 over 2 equals minus 3 over 2 squared plus 5 times minus 3 over 2 minus 2. So that's 9 over 4 minus 15 over 2 minus 2. It's minus 29 over 4. So the point of contact would be minus 3 over 2 minus 29 over 4. Now we have the point of contact, we have the gradient of the normal. We can now find the equation of the normal. So y equals mx plus c minus 29 over 4 equals the gradient of the normal minus a half times minus 3 over 2 plus c minus 29 over 4 equals 3 over 4 plus c. C is going to be minus 32 over 4, which is minus 8. So y equals minus a half x minus 8, or a better form would be 2y equals minus x minus 16. Even better, 2y plus x plus 16 equals 0. These three equivalent forms represent the equation of the normal to f of x at the point minus 3 over 2 minus 29 over 4. Again, we can illustrate all of this graphically. The equation of the tangent in green is given by, so tangent is given by 4y equals 8x minus 17, and we can verify this. The gradient of the normal is minus a half. That means that the gradient of the tangent is 2. Point of contact is minus 3 over 2 minus 29 over 4. So the gradient of the equation of the tangent rather, y equals mx plus c. So minus 29 over 4 equals 2 times minus 3 over 2 plus c. So c equals minus 17 over 4. So y equals 2x minus 17 over 4, which is better written as 4y equals 8x minus 17. Curve has equation f of x equals 3x squared minus 3x minus 2. We're required to find the equation of the tangent, which is perpendicular to y equals 2x minus 2, and then we're required to find the equation of the normal to the curve perpendicular to y minus x plus 5 equals 0. Okay, so we've already got f of x, which is 3x squared minus 3x minus 2. We are now just going to call every other function something else. So the tangent, we're going to call g of x. Y equals 2x minus 2, we will call h of x. And we'll worry about part b when we get it. So the tangent is now perpendicular to the straight line h of x. So we know, because g of x is now perpendicular to h of x, that means that the gradient of g times the gradient of h is going to be negative 1. In other words, h of x, which has a gradient 2, right? To find the gradient of g, we take the negative reciprocal of 2. So the gradient of g will be minus 1 over 2. If you're not sure about that, the gradient of g times the gradient of h, which is 2, equals negative 1. Divide both sides by 2. The gradient of g is minus a half. So g of x equals mx plus c. We've got the value of m, the gradient, which is minus a half. We now need a point of contact. Again, they've not given us a point of contact. We have to work out. So we know that the gradient of g is minus a half. G we know is a tangent. The gradient of a tangent to a curve is represented by the derivative function. So we've got the curve f of x. We're going to differentiate f of x to get f prime x, which gives us 6x minus 3. 6x minus 3 represents the gradient of a tangent to f. We know the gradient of the tangent is minus a half. So 6x minus 3 equals minus a half. 6x equals 3 minus a half is 2.5, so it's 5 over 2. Therefore, x equals 5 over 12. X equals 5 over 12 now represents the x coordinate of the point of contact between the tangent and the curve. To find the y coordinate of the point of contact, we substitute x equals 5 over 12 into f of x. So f of 5 over 12 equals 3 times 5 over 12 squared minus 3 times 5 over 12 minus 2. That's going to be 75 over 144 minus 15 over 12 minus 2. Minus 393 over 144. So the point contact will be 5 over 12 minus 393 over 140. So the equation of the tangent, y equals mx plus c, minus 393 over 144 equals the gradient of the tangent, which is minus a half, times 5 over 12 plus c minus 393 over 144 equals minus 5 over 24 plus c. So c equals minus 121 over 48. So the equation of the tangent is y equals minus a half x minus 121 over 48. Again, we can illustrate this graphically. So we've got the function f of x, which is the quadratic function. We've got the point of contact, which is 5 over 12 minus 393 over 144. And we have the tangent y equals minus half x minus 121 over 48. And we can further illustrate this by drawing in straight line y equals 2x minus 2, which we can see is perpendicular to the tangent. Okay, part B, we're required to find the equation of the normal perpendicular to y equals minus x plus 5 equals 0. Okay, so this function over here, we are first going to write in standard form. Y equals x minus 5, and let's just call this function j of x. Now the normal is perpendicular to j of x. So let's call the normal k of x. Because k of x is perpendicular to j of x, we know, so k of x is perpendicular to j of x. We know the gradient of k times the gradient of j is going to be negative 1. That's the definition for perpendicular lines. The gradient of j is 1. Gradient of k times 1 equals negative 1. That means that the gradient of k has to be negative 1. So we've got the gradient of our normal k of x. Now again, we don't have a point of contact, so we have to find that out. Now f of x equals 3x squared minus 3x minus 2. We know that when we differentiate a function, we're going to get the gradient function, the gradient of a tangent. So f prime x will be 6x minus 3. Six x minus 3 represents the gradient of the tangent to f at a particular point. Now, the gradient of k, our normal, is negative 1. That means that the gradient of the tangent is going to be 1. So, in other words, 6x minus 3 equals 1. 6x equals 4. X equals 2/3. X equals 2/3 represents the x coordinate of the point of contact between the tangent and the curve. So to find the point of contact, we can substitute x equals 2/3 into f of x. So f of 2/3 is 3 times 2/3 squared minus 3 times 2/3 minus 2. That's 3 times 4 over 9 minus 2 minus 2. That will be 4/3 minus 4, which is minus 8 over 3. So the point of contact between the tangent and the curve is the point 2/3 minus 8/3. This point of contact will be the point of contact between the normal and the curve. And we have the gradient of the normal, we have the point of contact of the normal. We can now find the equation of the normal. So y equals mx plus c minus 8/3 equals minus 1 times 2/3 plus c. C is going to be minus 6/3, which is negative 2. So y equals minus x minus 2. This is the equation of the normal, which is k of x, and you can just write that as k of x equals minus x minus 2. We can illustrate this graphically. The equation of the tangent in green is given by 3y equals 3x minus 10, and we can verify this. The gradient of the tangent is 1 because the gradient of the normal is negative 1. Point of contact is 2/3 minus 8/3. Y equals mx plus c minus 8/3 equals 1 times 2/3 plus c. C equals minus 10/3. So y equals x minus 10/3. 3y equals 3x minus 10. And that's the equation of the tangent again. The equation of the tangent is just there to illustrate the problem. We were required to find the equation of the normal, which was y equals minus x minus 2. Koeber's equation, y equals 3x squared plus x minus 2. Again, we're going to call this function f of x. We're required to find the equation of the tangent perpendicular to y equals minus x minus 5. We'll worry about the normal later. So this function we're going to call g of x equals minus x minus 5. Doesn't matter what you call these functions. The tangent we will call h of x. Now we are told that the tangent is perpendicular to the straight line y equals minus x minus 5. In other words, h of x is perpendicular to g of x. That means that the gradient of h times the gradient of g is negative 1. That's the definition of perpendicular lines. The gradient of g is the coefficient of x in standard form, which is negative 1. That means that the gradient of h must be 1. So we've got the gradient of h, it's 1. We now just need to find the point of contact. Now, we're not given a point of contact, we have to work it out. We know the gradient of h is 1. H is the tangent to f of x. And we also know that when you find the derivative function of a curve, which is the gradient function, we are establishing the gradient of the tangent to the curve. So f prime x, the derivative function, equals 6x plus 1. 6x plus 1 represents the gradient of a tangent to the curve f of x. We know that the tangent h of x has got a gradient of 1, so we can say that 6x plus 1 equals 1, 6x equals 0, x equals 0. X equals 0, this is the x coordinate of the point of contact between the tangent and the curve. To find the y coordinate of the point of contact, we're going to substitute x equals 0 into the curve. So f of 0 is 3 times 0 squared plus 0 minus 2, which is minus 2. 0 minus 2 therefore represents the point of contact between the tangent and the curve f of x. So we have the point of contact. Recall that we're trying to find the equation of the tangent h of x. So y equals mx plus c. We have the gradient of the tangent, which is 1, and we've got the point of contact 0 minus 2. So y equals mx plus c, minus 2 equals, the gradient is 1, x is 0, so c equals minus 2. So y equals x minus 2, and if you like, this is h of x, which equals x minus 2, and this is the equation of the tangent to f of x, and this tangent is perpendicular to g of x, and we're going to illustrate that graphically as well. We can clearly see that the tangent in purple is perpendicular to the normal in blue. We're now required to find the equation of the normal to the curve perpendicular to y minus 2x plus 5 equals 0. Okay, again, we are going to write this in standard form. So we'll call this j of x. So y equals 2x minus 5. J of x equals 2x minus 5. We are told that the normal is perpendicular to j of x. So the normal, let's just call the normal k of x. We are told that k of x is perpendicular to j of x. That means the gradient of k times the gradient of j is negative 1. We write this in standard form so that we could easily get the gradient of j, which is 2. So the gradient of k is the negative reciprocal of 2, which is minus a half. So we've got the gradient of k, which is our normal. Again, y equals mx plus c is the general equation of a straight line. To find the equation of a straight line, we need to know the gradient and one point, and that's going to be the point of contact. We've got the gradient, which is minus a half of the normal, and now I need the point of contact. So we're not given the point of contact, we need to work it out. F of x equals 3x squared plus x minus 2. The derivative function is the gradient function, so differentiating f of x gives us f prime x, which represents the gradient of a tangent to f of x. F prime x equals 6x plus 1. This expression represents the gradient of a tangent to f of x. We have the gradient of k, which is a normal, is minus a half. The gradient of the tangent is therefore going to be the negative reciprocal of that, which is going to be 2. We can now equate the gradient of the tangent 6x plus 1 to 2 because they're equivalent. They both represent the gradient of a tangent. So 6x equals 1, x equals 1 over 6. X equals 1 over 6 represents the x-coordinate of the point of contact between the tangent and the curve. To find the point of contact, the y-coordinate of the point of contact, we can substitute x equals a sixth into f of x, which is 3 times 1 over 6 squared plus 1 over 6 minus 2. It's 3 over 36 plus 1 over 6 minus 2. It's 1 over 12 plus 1 over 6 minus 2. Which is minus 21 over 12. So the point of contact is the point 1 over 6 minus 21 over 12. We now have the point of contact between the tangent and the curve, and we have the gradient of the tangent, which is 2. Y equals mx plus c. minus 21 over 12 equals 2 times 1 over 6 plus c, minus 21 over 12 equals the third plus c, c equals minus 25 over 12, y equals 2x minus 25 over 12, which is perhaps better written as 12y equals 24x minus 25. And this represents the equation of the tangent to f of x at the point 1 over 6 minus 21 over 12. And we can illustrate this graphically. We can now determine the equation of the normal, so y equals mx plus c minus 21 over 12 equals minus a half times 1 over 6 plus c, minus 21 over 12 equals minus 1 over 12 plus c. C will be minus 20 over 12, which is minus 5 over 3. So y equals minus a half x minus 5 over 3. Better written as 6y equals minus 3x minus 10, or rather 6y plus 3x equals plus 10 equals 0. And this represents the equation of the normal to the curve at the point 1 over 6 minus 21 over 12, and we can illustrate this graphically as well, which is given by 6y plus 3x plus 10 equals 0. The blue-purple line is the equation of the tangent to the curve at the point of contact 1 over 6 minus 21 over 12, which is given by 12y equals 24x minus 25.